let's start with a few examples here. First question I've got 6xyz to the power of 2. Second question I have is 3x to the power of 3y divided by 9xy squared. Question 3, I have xy squared minus 4y squared x. Question 4, I have 4 over 7t to the power of 2. Question 5, I have xy to the power of 3 over 3 all to the power of 2. Let's go through the first one. The first question here, what I want to do is take that power and distribute it to every single part of my entire expression on the inside of the brackets. If there's a power there, I multiply it. So hypothetically, if I had a power of 2, this would become times, and it would become x to the power of 4, because 2 times 2 is 4. But at the moment, there's no power, and no power means that it's power of 1. So it's imaginary 1. And so 2 times 1 is 2, 2 times 1 is 2, and 2 times 1 is 2. And when you have a number, it's also to the power of 1. And a number is always to the power of 1. So the number will also be to the power of 2. So we're going to take each of those power of 1s, and we're going to change it into power of 2. So it's going to become 6 to the power of 2, x to the power of 2, y to the power of 2, and z to the power of 2. And 6 to the power of 2 is 36. And then x squared, and y squared, then z squared. All right, next. 3x cubed y divided by 9xy squared. I like to rewrite this question as a division sum. And then simplify it. Now 3 can go into 9 3 times. X can go into cubed x squared times. Y can go into y squared y times. And that's the answer there. Now how did I get that? So the first thing is, step 1, I took the first fraction and I put it at the top. 3x to the power of 3y. Took the second one, brought it to the bottom, 9xy squared. And what you notice is I'm grouping it up quickly. So it will be, I'm grouping the 3 and the 9, grouping the x's, grouping the y's. And when I don't have a power, I have a power of 1. So there's a power of 1 here and there's a power of 1 here. The 3 over 9 is simplifying because I can divide the top and the bottom by 3 to become 1 over 3. The powers, when you divide, you subtract powers. So when you divide, 3 at the top minuses the 1 to become x to the power of 2 at the top. The same thing applies here. 1 at the top minuses 2 at the bottom, which would become minus 1 at the top. At this point, we have already addressed each of the 3 parts. We've got 1 over 3 from the first one, we've got x squared from that one, and we've got y to the minus 1 from the third part. We don't like negative powers. So if you get a negative power, you move it from the top to the bottom or from the bottom to the top, and you change it into a positive power. And we normally ignore 1. We just write it as x squared over 3y. And that'll be the final answer there with those kind of powers. All right. The next one, whenever you square something, you can write it twice. But everything is to the power of 1 in this case. Exact same principle applies like we did here. We multiplied each part. We're going to multiply each part here as well. So we take 2 times 1, 2 times 1, and 2 times 1. That becomes 4 squared over 7 squared times t squared. 4 squared is 16. 7 squared is 49. T squared says t squared. And it's done. Same rule applies there. Okay. Over here, if you notice, we actually have like terms. We have y squared and x. Even though they're reversed, it's still like terms, which means this is an imaginary 1, and 1 minus 4 is negative 3 xy squared. Like terms for that one. For the next one, same rule applies. If you have no power, put a power of 1. Then take the power from the outside and multiply it in to every single power. So step 1, this is going to be x. 1 times 2 is 2. 3 times 2 is 6. 1 times 2 is 2. If you have a number to a power, make it into a normal number. So 9. Leave all the other letters or variables the same. And we're done there. Okay.